Hello everyone. Today I'm going to teach you how to solve more simultaneous equations. I explained in my first video on simultaneous equations how we can just use subtraction to be able to find the value of x and y. So how we can change your favorite variable from negative to positive. So how we can make both of them positive and how we can make both coefficients the same to be able to subtract so we can cancel out that one, all right? Now, let's have a look at some examples here. Here are the steps that I followed in my previous video, so we can follow exactly the same steps, so just subtractions, right? So this is the first pair of simultaneous equations. I have y minus 3x equals 3 and x minus 2y equals 4. Now, to be able to solve this one, first of all, you have to do a little bit of a rearrangement. So I'd like to swap the x and minus 2y for the second one. So I'm going to rewrite the top one as it is, okay? Minus 3x equals 3. And the second one becomes minus 2y minus x equals 4, right? So x and y should be aligned nicely under so that we can subtract. Right, so here I have y here, I have minus 2y, and then I have minus 3x minus x. Now I need to decide which variable I can cancel out easily, I can get rid of easily. Right, I'd like to choose the y's, all right? Now, the first one is y, the second one is minus 2y. So I'm going to first change the second one to a positive. So by multiplying by minus every single term. So this one, the second one, becomes 2y plus x equals minus 4, okay? And so my both equations are going to look like that. I'm going to, again, line them nicely. And the second one is 2y plus x equals minus 4. See what I did here? I changed the minus to a plus. And then this is y, this is 2y. So what do I need to do now? I have to multiply the first equation, which means every single term of the first equation, by 2 to be able to have the coefficients the same. So by 2, and this one by 2. So the first one becomes 2y minus 6x equals 6, right? And then 2y plus x equals minus 4. Can you see how I made the y's both with the same coefficient, both the same sign? And then now I can subtract easily, and I know that I'm going to get rid of the 2y's. 2y take away 2y is 0, right? Cancel them out. Minus 6x minus x becomes minus 7x. It is minus, remember, minus plus x or minus x minus 7x equals. Now, 4 minus 6 minus minus 4. 6 minus minus 4 is the same as 6 plus 4, and the answer is going to be 10. So divide by minus 7 both sides, divide by minus 7, and the answer is going to be x equals 10, so minus 10 over 7, or minus 1 and 3/7. All right, so I'm going to leave it as a fraction, right? So I can get exact value of the y. Now is the time to substitute. I'm going to choose the first equation. I'm going to put this in a circle so I know how much the x is. Now, y equals minus 3. Now, x is minus 10 over 7, so times minus 10 over 7 equals 3, right? So y minus 3 times minus 10 over 7 becomes plus 30 over 7 equals 3. Now, to be able to find the y, you take away minus 30 over 7 on both sides. And so y equals 3 minus 30 over 7. I put both of them under the same fraction. Right, so y equals minus 7, 7, 7, 30 under the same denominator. So this one becomes 21. 21 over 7 is multiplied by 7, numerator and denominator. And so can you see the answer becomes minus 9 over 7. And this is my y, so the value of y, or minus 1 and 2/7. Okay, so my solutions are, I'm going to put this in a circle as well. My solutions are x equals minus 1 and 3 over 7, and y equals minus 1 and 2 over 7. These two. Okay, let's have a look at another example. 3a plus c equals 8, 2a minus c equals 8. Again, I like to choose the method of subtraction to be able to subtract them. Then first I decide on which letter could be easier to get rid of, and are they the same sign as well, so same coefficient, both of them positive. Remember, now I can see c and a c, both of them are, so its coefficient is here plus 1 and here is minus 1, so I can change the minus 1 to plus 1. So this is the bottom one. If I multiply all of them by minus 1, all the terms are multiplied by minus 1, multiplied by minus 1, multiplied by minus 1. Then the second one becomes, so minus 2a plus c equals minus 7. And the top one stays the same, 3a plus c equals 8. Now, can you see how I can get rid of the c easily? And take away 3a minus 3a, 2a becomes 5a. Cancel these two out. 8 minus 7 becomes 15. And so divide by 5 both sides, divide by 5, divide by 5. So a is 3. And then cancel these two out. Okay, a is 3. Now let's find the value of c. I go to my original equations, and I like to use the second one because it seems with less coefficients, right? So 2y minus c, so minus 3. Let's substitute straight away equals. It is minus c, 2a minus c equals 7. So I substitute the a, so 2 times 3, okay, minus c equals 7. 6 minus c equals 7. And if I get rid of the 6 minus 6 minus 6, I'm going to have minus 6 equals 7, minus 6 equals, so minus c equals 1, divide by minus 1 both sides, then c is going to be minus 1. So these are the solutions of this simultaneous equation. A equals c minus 1. Right, again, now I don't have, so the first equation says 2y equals x plus 10. The second one, y equals 2x minus 10, minus 7. I need to do a little rearrangement as well. And here, of course, I like to rearrange both of them, keeping the y, so the general form, y plus x equals the number. Okay, so for the first one, I'm going to get rid of the x on both sides. So minus x, so the first one becomes 2y minus x equals 10, right? And then the second one, again, I get rid of the 2x on the right-hand side, minus 2x, and then so the second one becomes y minus 2x, okay, equals minus 7. So I just rearrange. I did not change anything. I made sure, okay, that y and the x are both on the left-hand side. So then when I subtract, I can see that I've done the right thing. Right, see, I have y's, both of them are positive. And so that's what I want, okay? But the coefficient is not the same. So I'm going to change the coefficient of the y in the second equation to 2. And how I do that? By multiplying by 2 every single term of the second equation. And so this is what I'm going to say. I rewrite the first equation exactly as it is, and the second one becomes 2y minus 4x equals 2 times minus 4 is minus 14. Again, I'm going to use a subtraction. That's my whole idea. 2y minus 2y is 0, cancel them out. Minus 6. Now here you have to be careful when you deal with negative and negative, take away a negative number. So minus 6 minus minus 4 is the same as minus 6 plus 4. And minus 6 minus x plus 4x becomes 3x. And 10 minus minus 14 is the same as 10 plus 14. And so the answer is going to be 24. Divide by 3 both sides. Right, so the answer is x equals 8. 24 divided by 3 equals 8. Let's find the value of y. I'm going to use the second equation of the original equation because it has less coefficients, right? Y equals smaller coefficient, I should say, smaller numbers. Minus 7, I substitute the x, y equals 2 times 8 minus 7. Y equals 2 times 8 is 16. 16, take away 7, the answer is going to be 9. And these are the answers of my equation. You see what I did? I rearranged, and then I make sure the letter that I get rid of have positive sign in front of them, are both positive, and the coefficients are the same. Let's have a look at this one. Again, I'm going to have to do a little rearrangement here because I want the x and the y on the same, on the left-hand side of the equation. So I'm going to stick to the classic way of the equation, right? Now here, I have y, but x is on the right-hand side. In the first one is okay. Now the second one, how do I put the x on the left-hand side? So I need to get rid of the x on the right-hand side. So minus x, okay? And so the second equation becomes y minus x equals minus 2. Yeah, but I want to have x in the first position. So when I take away, both of them are lined up nicely. So the second equation from this form came to this form. Both of them are the same thing. Now, let's put both equations, my simultaneous equations, nicely and neatly. Line them up. And here, this one will be minus x plus y equals minus 2. Now, I'd like to change, which one do I change? I like to do both of them. Can you see? X's are different coefficient. This is 4, this is minus 1. And the y's mean minus 1 and plus 1. So I could change easily the minus 1 here to plus 1 by multiplying every single term of my first equation multiplied by minus 1. So y's are both positive, all right? So I can get rid of them by subtracting. Again, subtraction, that's what I like to use, right? So the first one becomes minus 4x. Minus 1 times minus 1 becomes plus y equals minus 17. And the second one becomes minus x, it stays as it is, plus 2 equals minus 2. And can you see how both y's, same coefficient and same positive sign? I can take away easily. Minus 4x minus minus x is the same as minus 4x plus x, so minus 3x. Cancel these two out, equals minus 17 minus minus 2 is the same as minus 17 plus 2, so minus 15. I divide by minus 3x both sides, minus 3, divide by minus 3 so that I can get rid of the minus 3 here. And I'm gonna have the value of x, which is x equals minus 15 divided by minus 5. The answer is going to be divided by minus 3. The answer is going to be positive 5 because you divide two negative numbers. And now we will substitute the second one. I find it easier to substitute. All right, less coefficients for x and y, and the number here, it is smaller than 17. So why not choose the second one? And let's substitute straight away. So y equals 5, take away 2. Y equals 3. There you go. These are my solutions. X equals 5 and y equals 3. Again, I'm using subtraction, but I make sure I change the negative sign to positive sign by multiplying every single term of that equation that has that negative letter to positive. Right, how about this one here? It says minus 2x plus 3y equals 9, x minus 1 minus y equals 3. Now, x's and y's on both of them are negative. Now, which one would be easier to change to? Remember, both of them should be positive. Both of them should have the same coefficient. Now, the second one, I like to choose the x because I can see it could be easier to change. Now, I could change the first one to 2x by multiplying every single one of the first one by minus 1, every single expression, times minus 1 times minus 1. So the first one becomes 2x minus 3y, right, equals minus 9. And the second equation, now I have to change the coefficient of the x to 2. And so I multiply the second one by 2 every single term or every single expression of the second equation by 2. So the second equation becomes 2x minus y times 2 minus 2y equals 6, right? And then now I get rid of the 2 x's by doing the subtraction. So this one becomes minus y minus minus 2y is the same as minus 1y plus 2y. So y equals minus 9 minus minus 6. So the answer to the second one becomes minus 9 minus 6. So it becomes minus 15. So y equals minus 15. So let's have a look. Minus 2x become 2x plus 3y, it is a 3y minus 3y here equals minus 9. So minus 3y, yes, becomes minus y then. Minus 3y minus minus 2y, so it's minus 3y plus 2y. So the answer is going to be minus y here. So y itself, it is 15, right? It is 15. And then the x, I'm going to choose the second equation to be able to find the value of the x. And so this is what I have, x minus 15 equals 3. How do I get rid of minus 15? By adding 15 on both sides, plus 15, plus 15. So x equals 18. That's it. These are the solution of my second, second variable. So x 18 and y 15. Okay, now this is something that you can work independently. I see here both x and y's have negative signs, but x's, both of them have different, so but they have the same, so minus 2, 2. You can change the 2x, the minus 2x here to plus 2x by multiplying every single term by minus 1. So 2x minus 2x becomes 2x, all right? So the first one will look like this one. So 2x minus y equals plus 2, so just 2. And the second one stays the same, minus 3y equals 6. Can you see? Again, use a subtraction and then continue from here. Be careful, you need to find both the values of x and the values of y. Let's have a look at another one. So that is the last one. So work this one independently. As I said in my previous video, you can choose any method you want if you feel confident enough with following the method of adding both equations or subtracting both equations. So if you can switch between one or the other method or the method of substitution from the beginning, whichever you want. But I chose the subtraction so that you can see then if you subtract two positive numbers with the same coefficient, two positive expressions with the same coefficient, they become 0. So it could be easy for you to realize how to cancel out that variable that you have chosen. So yeah, thank you very much for supporting my steps. Have a lovely day. Bye-bye.